Hi, my name is Walter Nahara. I'm a student at California State University, LA, and these are my notes for week 7 of CS 4540. Today we'll be discussing a little bit more about what AI agents and what they do. So to start, traditional AI systems are the simplest form of AI. They're programs which rely on pre-programmed algorithms and instructions to perform their tasks while lacking the ability to adapt and or generate new content. They are excellent for tasks with well-defined problems such as analyzing data, simulate specific scenarios, and being the basis of recommendation engines. AI agents are thus a higher form of traditional AI systems. They possess much of the same components of a traditional AI system, but with the additional capabilities of generating and or adapting to new content and capable of remembering past interactions slash information. They often employ the uses of tools and systems in accomplishing their goals. While they do express a sense of autonomy in their process, they're limited to within the range of what the developers established in their programs. Now, AI agents are utilizing AI models as its core reasoning engine. They interpret and respond to human instructions in a meaningful way, analyze information, make decisions, and devise strategies to solve problems. And they gather information, test actions, and observe the results of those actions. Now, AI agents are commonly implemented in LLMs, so things like ChatGPT. This is because these models act as the brain of the agent, providing a means to interpret user instructions, maintain the context of the conversation, and define a plan and determine which tools to use. AI agents should only be employed in system if the task requires flexibility, aka if the predetermined workflow falls short in every scenario, thus requiring more flexibility to accomplish the task. So to give an example of what this means, if the user asks the program questions or simple requests that aligns with the program's capabilities, aka fits all queries, then there should be no need to introduce an AI agent as the program is capable of functioning and completing tasks without external tools. However, if a user asks the program questions that have numerous factors at play or set questions that perfectly align with the program's trained data, then an AI agent should be introduced to provide the program with the flexibility to answer properly in these cases. Until recently, computer programs were restricted to predetermined workflows with corresponding number of if/else statements depending on complexity, ensuring that their deployment were limited to extremely narrow tasks. AI agents allow these programs to broaden their abilities in terms of problem solving, thus allowing them to perform far more complex tasks than previously asked of them. Now, an agent can perform any task we implement via tools to complete actions. The designs of the tools is very important and has a great impact on the quality of your agents. Some tasks require very specific tools to be developed, while other tasks can be accomplished with general purpose tools. Commonly used tools in AI agents includes rep search, which allows the agent to fetch up-to-date information from the internet, image generation, which helps create images based on text description, retrieval, retrieves information from an external source, and then API interface, which allows them to interact with an external API. Tools should contain a textual description of what the function does, a callable or something to perform an action, arguments with typing, and as an optional component, outputs with typing. In the case of LLMs, we teach them about the existence of tools and ask the model to generate text in the form of code that will invoke tools when it needs to. It's the responsibility of the agent to parse the LLM's output, recognize that a tool call is required, and invoke the tool on the LLM's behalf, with the output from the tool be sent back to the LLM, which will compose its final response for the user. The output from a tool call is another type of message in the conversation. However, these tool calling steps are typically not shown to the user. Agents work in a continuous cycle of thought, which is when the LLM part of the agent decides what the next step should be. Act, the agent takes an action by calling the tools with the associated arguments and observe. The model reflects on the response from the tool. In many agent frameworks, the rules and guidelines are embedded directly into the system prompt, ensuring that every cycle adheres to a defined logic. Now, we're going to go into more detail of what these three steps mean. Now, and the agent thoughts are responsible for assessing current observations and decide what the next action should be. Through this process, the agent can break down complex problems into smaller, more manageable steps, reflect on past experiences, and continuously adjust its plan based on new information. Type of thoughts include planning, analysis, decision making, problem solving, memory integration, self reflection, goal setting, and prioritization. A key method is the REACT approach, which is the concatenation of think with act, a simple technique that appends the model to think step by step before proceeding to decode the next token, allowing for the model to consider sub steps in more details to prevent less errors from occurring than trying to generate the final solution directly. Actions are the concrete steps an AI agent takes to interact with its environment utilizing the tools provided. There are multiple types of agents that take actions differently. JSON agent, which is the action to take it specified in JSON format. Code agent, the agent writes a code block that is interpreted externally. And then the function calling agent, a subcategory of the JSON agent, which has been fine tuned to generate a new message for each action. And actions themselves can serve many purposes. They can gather information, aka perform web searches, query databases, or retrieve documents. Tool usage, like making API calls, running calculations, and executing code. Environmental interaction, which means manipulating digital interfaces or controlling physical devices. And lastly, communication, engaging with users via chat or collaborating with other agents. One crucial part of an agent is the ability to stop generating new tokens when an action is complete, preventing unintended output and ensuring that the agent's response is clear and precise. The stop and parse approach is a method that ensures that the agent's output is structured and predictable. The agent outputs its intended action in a clear, predetermined format. Once the action is complete, the agent stops generating additional tokens, preventing extra or erroneous outputs from being outputted. And an external parser reads the formatted action, determines which tool to call, and extracts the required parameters. Now, let's get into more detail about what a code agent is. Code agents generate executable code block, typically in a high level language like Python, with several advantages compared to JSON agents. Code can naturally represent complex logic, including loops, conditional, and nested functions, providing greater flexibility than JSON. Modularity and usability, which means generated code can include functions and modules that are reusable across different actions or tasks. Enhanced debuggability with a well-defined programming syntax, code errors are often easier to detect and correct. And then lastly, direct integration. Code agents can integrate directly with external libraries and APIs, enabling more complex operations such as data processing or real-time decision making. This method also follows the stop and parse approach by clearly delimiting the code block and signaling when execution is complete. Observations are how an agent perceives the consequences of its actions, providing crucial information that fuels the agent's thought process and guides future actions, aka acting like signals from the environment. In the observation phase, the agent collects feedback, aka receives data or confirmation that its actions were successful or not, integrates the new information into its existing context, effectively updating its memory, and uses this updated context to refine subsequent thoughts and actions. It ensures that the agent remains dynamically aligned with its goal, constantly learning and adjusting based on real world outcomes. Some types of observation include system feedback, which is error messages, successful notification, and status codes, data changes, which is database updates, file system modification, and state changes, environmental data, sensor readings, system metrics, and resource usage, response analysis, API responses, query results, computation outputs, and time-based events, which are deadlines when it's reached and scheduled tasks completed. In a little bit, I'm going to be showing you a program that uses AI agents in order to visualize how they work. Now, I created these two programs using a tutorial video from Code Basics, and the programs were built on PyCharm Community Edition, which is a Python integrated development environment. I also use Grok Cloud, which is a cloud-based services that provides access to Grok's AI tools and hardware. I also use the Phi library, which is used for functional programming in Python, and then .env, which is a library that loads environmental variables from a .env file into an application's runtime environment. These right here are the two programs that I created using the video. Now, the first program is a simple chatbot where we import the agent and the Grok from the Phi library And then we also import the .NET to use the load underscore .env, which allows us to load our .env file. Now, I'm not going to show what's in this file as it contains our API key from the Grok Cloud services, which is a personal key given to you. As such, I can't show that publicly. And right here at the agent.print response is where you would like type the responses. So let's say I type explain the different phases of the moon. And then I run the file up here. It takes a while to load. And then here we go. We have the message that I type, explain the different phases of the moon. And then we have our response that goes into detail about the different phases of the moon. So it talks about the new moon, the first quarter, the full moon, and things like that. But this is just a very simple like Grok 8 agent at the moment. If we want to do something different, let's say finance, then we have this program right here. In the second program, the difference here is that we import a tool from the file library called Y Finance tools. In our agent, we add these extra steps. So first off, we add the tools, which will provide what tools the program is capable of using. For example, right here we have the Y Finance tools as stated before. With different parameters so that when it uses this tool, it'll give us information about the stock price, the what analyst recommends, and then what the stocks mean. And then right here, so tool calls, this is just so we can see like how the program calls the tools. It's typically not shown as I stated before, but it's just so we can like see it in this program along with the debug mode. And then right here we have the instructions. Now these instructions, it tells the program what the parameters that it can work with. So is to use tables to display data. The second instruction, if you don't know this company symbol, please you get company symbol tool, even if it's not a public company. And then the last one says make sure the company name is converted to the appropriate stock symbol before querying data. Now it says here get company symbol tool. So what's that? Well, if you look at the tools, then we have something called the get company symbol, and this is what the tool is. So we have a method which parses the company string, which is say right here in the response, and it gives the instruction. It says use this function to get the symbol for a company. It gives us the return, and then it gives us the arguments. So the company string is the name of the company, and then it's to return the string, which is the symbol for the company. And then over here we have a list of different symbols and their corresponding symbols. So like Phi Data is MSFT, and then Apple is AAPL, Google is GOOGL, and then at the end we have a return to return unknown if like it can't find any data from the symbols. So we here in the agent print response, we have summarize and compare analysis recommendation for fundaments for TSLL and Apple. Now notice how this is correctly written in its stock symbol. However, Apple is not the stock symbol that represents Apple in the stock market. So what it will do is that it'll look at this, it'll call in the get company symbol for both. It won't do anything different here because it's already a symbol, but because of Apple, because of the third instruction, it'll look at the table for symbols, and then it'll find if Apple is on it, and then once it finds Apple, it'll convert it into the right symbol, so AAPL. So if we run it right now, so as we can see here, it converts the string Apple into the correct symbol, and then as such, we can finally get the stock for both TSLL and AAPL. It'll give us the recommendation, and then tell us summarize the information, and that's how the agent in this program works. As always, we always reference the materials that we used during the lecture and the notes. First off, we have two videos from Code Basics. The first video summarizes what AI agents are, and the second video is the tutorial video that I used to grade those two programs that I showcased earlier. And then we also have Hugging Face and two particular documents. The first is an article discussing small agent, which is a small agent library. The second link is an AI course that discusses what AI agents are, what AI agent does during each step of its cycle, and And then it briefly talks about Small Agent. So they're both kind of like intertwined with each other. This is the end of my videos. Thank you for watching and have a good day.